What's up, Mr. O here, and today we're going to learn how to graph quadratic function in a form of vertex form, and we're going to do some graphing about quadratic equation and inequalities. Okay, at this time we should all know that the form of quadratic equation in vertex form is in y is equal to a quantity x minus h squared plus k, wherein your h and k are your vertex. Okay, the vertex could be the minimum or the maximum. Depends if the A is the concave upward, then that's going to be a minimum. If concave up, that's going to be a maximum. Okay. There are also some knowing the axis of symmetry, the table of values, but we're gonna go ahead on those things as we keep going on this video. Okay, so let's go here now. Describe the transformation of each function compared to its parent function. The parent function of a quadratic equation is y is equal to x squared, wherein we know it opens upward. So if we have x plus 7 squared minus 1, we know that the plus 7 tells us that it's gonna shift, translate to the left by 7 units. And the minus 1 outside is telling you that it's gonna go down by 1 unit. Okay. All right, there you go. Now here, f of x equal to 0.3 x squared plus 2. The zero point 0.3 here is a coefficient of a that is less than 1, but it's bigger than 0. Anytime that the value of a is between 0 to 1, or it's between a is bigger than negative 1, less than 0, so it's going to be like a negative zero point 0.5, negative zero point 0.6. That is telling this a compression with a scale factor of zero point 0.3. Okay, the scale factor of zero point 0.3 or by zero point 0.3. The mean of compression, if your parent function, which u shape, which is y is equal to x squared, the value of a there is equal to 1. When it becomes less than 1, like a zero point 0.3 x squared, it becomes wider, a wider compressed compressed parabola. If you can say compress, the wings of the parabola becomes wider. If we have a y something smaller than zero point 0.3, is like a zero point 0.1 x squared, so it's going to be way wider than that one. Okay, so if something bigger than 1, which is y is equal to like 2x squared, it becomes narrower graph. Okay, so for this case here, let me clear everything here. So again, this is a zero point 0.3, so it's a compression with a scale factor of 3. Compression with a scale factor of zero point 0.3, and there's a plus 2 there, so it goes shift up by 2 units. Okay, all right, there you go. It's not always that we have a fraction or decimal. It's always going to be a compression or something smaller than 1 but bigger than 0. A 5 halves is a fraction. That means it's 2.5, and that's bigger than 1. Again, every time it's bigger than 1, it's not going to be compression. This time it's going to be a vertically stretch. Vertically stretch anything when the a is bigger than 1, or if a is like less than negative 1, like negative 2, negative 3, negative 4. Okay, so the numerical digit has to be bigger than 1, basically. So vertically stretch meaning say it's going to be a wider than the parent function. Okay, the x minus 6 here telling us that's going to go right 6. Okay, to make sure you're not going to confuse with the a less than negative 1, the idea there, if you have negative 5 halves x squared, it's still going to be vertically stretched because 5 halves is 2.5. The negative here is just telling you that it's open downward. But the digit here, the numerical value of 5 halves is still like 2.5, which is still less than negative 1. So that's why it's going to be a vertically stretched. It's still going to be narrow, although it's going to open downwards. Okay. All right. Number 4 here, it's negative outside, so it's going to reflect over the x-axis. So that's why it's going to open downward. The plus 3 is telling you that's going left 3. The plus 5 here is telling you that's going to translate up by 5 units. Okay? All right, that's how you describe the transformation of a function just by looking at the equation. Okay? Here, just by looking at the equation, we know the transformation here is going to go left 3, down 2. Okay? So you're gonna go left 3, 1, 2, 3, down 2. Okay, we can already identify the vertex. That's going to be negative 3, negative 2. Okay, and then we can identify values on numbers before negative 3, which are negative 2, negative 1, or after, I mean, and this will be negative 4, negative 5 there. We're gonna plug in this x values to our equation, to our function. So this will be now negative 2. Negative 2 plus 3 is 1. 1 squared is 1. Minus 2 is going to be negative 1. If we plug in negative 1 here, negative 1 plus 3 is going to be 2. 2 squared is 4. 4 minus 2 is going to be 2. So, and this will be the same, negative 1 and 2. Again, they're not always going to be the same. I would like you to double check your work when you make your table of values. And I'm just doing this one for the, for the sake of the time being. So negative 1, 2 right there, negative 2, negative 1 right there, reflection, reflection there. And there you go. That's the graph of this function here, okay? All right, again, this is your vertex here. The vertex is negative 3, negative 2. All right, there you go. The domain range is the domain range for the sake of everyone. Domain here is all real numbers. And the range there is the lowest point is negative 2. So therefore, negative 2 bracket parentheses. Okay, moving on. So this time we have a value of negative 2. So first we know it's going to be a vertical stretch because of the 2. The negative tells us it's going to reflect over the x-axis because it's negative. It opens downward. You can say also opens downward. The minus 1 telling us that you're going to go right 1. The plus 5 here tells you it's going to go up 5. Okay, so we're going to write 1 up 5. 1, 2, 3, 4, 5. Okay, that's our vertex. So the vertex here is 1 comma 5. That's your vertex. Okay, now we're gonna identify values of x before and after x. So I'm gonna put here 2 and 3, negative 0 and negative 1. So I'm gonna put the 0 first. So let me erase this portion here so we have room for the work. So if we plug in the 0 to the x, 0 minus 1 is negative 1 squared is positive 1 times negative 2 is negative 2 plus 5 is going to be 3. Um, if we plug in negative 1 minus 1 is negative 2. Negative 2 squared is 4. 4 times negative 2 is negative 8 plus 5 is negative 3 there. So therefore, we're going to have there negative 1, negative 3, 0, 3 here. Very good. And to save us some time, again, I would like you to double check, plug in the 2 here. 2 minus 1. Let me erase that portion. Okay. 2 minus 1 is 1. 1 squared is 1 times negative 2 is negative 2 plus 5 is 3. So it's the same. So I know this will be the same thing also. Reflection, reflection. If you notice the graph here, yeah, it opens downward and it's kind of a little like narrower. The parabola, the wings of the parabola are kind of closer. Okay, that's why it's vertically stretched. Okay, again, this is your vertex here, and in this case, that's a maximum point or maximum value of 5 because that's the highest point here. The domain here is all real numbers again, and the range here was the highest point, was the lowest point is negative infinity. The highest point there is a maximum is 5. All right, let's have a fraction here of 1/2 x squared minus 2. So since it's 1/2, you know it's going to be a compression with a scale factor of 1/2. What else? The minus 2 tells you that it's going to go down 2 units. Okay, so we know it's gonna go down to, so down to right here. So the vertex is 0, -2. Pick two numbers before 0 is -1, -2. Afterwards, it will be 1 and 2. So we plug in the -1 to the equation. -1 squared, 1/2. -1 squared is going to be 1 times 1/2 is 1/2. Minus 2 is going to be negative 1.5, negative 1.5 there. You can use your calculator to get the value, okay, of the y. Or if you plug in -2 here, -2 squared is 4. 4 times 1/2 is going to be 2. 2 minus 2 is 0. And to save us some time, this will be negative 1.5 and 0. And I would like to just double check the 1 and 2 on the x value there, okay? Because again, they're not always going to be the same always, so double check. So that's your vertex there. So -1, -1.5 right here. And this is 1, 1.5, and then 2, 0 right there, and -2, 0. If you notice, that's kind of wider this time, the points are wider. Okay, I need you to make it bolder, the points, so I can see it correctly if you plot it correct. Uh, the main there is all real numbers. The range, the lowest point there is -2. It's going up, parenthesis there, and this is bracket. And that's your vertex, which is 0, -2, right? There you go. So this time we're given a piecewise function x minus 4 squared minus 5. We know this will go right 4 and down 5. So we're going to go right 4, down 5, 1, 2, 3, 4, 5. Okay. Now I'm going to give you a little shortcut. If you have this is equal to 1 here and there's no number here, which is also 1, you can apply the 1, 3, 5. Okay. You can construct table. That's perfect. Okay. You can construct table. Remember that. What I'm trying to say with 135 is that from the vertex, since I know it's going upward here, I'm just gonna go up 1 over, up 3 over, and that will be the graph of my quadratic equation. If you would like me to prove it, here you go. The vertex there is 4, -5, 4, -5. So if I pick two numbers before 4, will be 3 and 2, after will be 5 and 6. So I'm going to plug in my x value here. If I plug in 3, 3 minus 4 is -1. -1 squared is 1. 1 minus 5 is -4. So this is -4. Look, where's 3, -4? 3, -4, right there. Okay, so it's the same thing. If we plug in the 2 there, 2 minus 4, that will give you a -2 squared, which is 4. 4 minus 5 is -1. Look, 2, -1, that point there. Okay, so that's another strategy in graphing it quickly. Again, the 135 works perfectly if there's a 1 here and there's a 1 there. Okay, all right. But we're doing the table of values is the perfect way. You learn your arithmetic and you learn where those coordinates come from, and you have an accurate answer. Okay. So anyway, so that's the graph of our x minus 4 squared minus 5, but we will only accept everything greater than or equal to 4. Where's 4? 4 is right here. So we will only accept this wing, this portion of the parabola, and that's closed. So this one is solid, and I am going to erase this portion here. Okay. Now let's do the next one here. It's a linear equation. Y equals 3x minus 2. That's the y equals mx plus b. So the y-intercept is -2. The slope is 3. 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3 over 1. If you notice, it's asking us to graph from 4 to the left because x less than 4, those are the numbers on the left of 4. And this is 4 here, so we're going to keep going. 1, 2, 3 over 4. And that's open. So this is open, connected, going down there. Now, that's the graph of our piecewise here. The domain here, since this graph is going to the left, this graph is going to the right, it's all real numbers. The range here, what's the lowest point? Since this is going down, so that's going to be -infinity. The highest point, this is going up, okay? Don't think that this is the highest point. This arrowhead's gonna keep going up there, so it's still going to be all real numbers. All right, thank you. Let's go to the next one here. I have here a piecewise function with three equations here. So the first one here, negative x squared minus 3, that is a parabola that opens downward. It reflects over the x-axis because it's negative x squared. So, and then opens downward. This is negative 3, so it's going to go down 3, 1, 2, 3. So since there's a 1 here, it's not going to affect my 1, 3, 5. Again, you can use the table of values. I suggest you use table of values here. Down 1 over, down 3 over. That's the applicable of the 1, 3, 5 here, okay? Now, and we will only accept the graph of if x is less than negative 1. Where's negative 1? Negative 1 is right here, so we will only accept this graph here. And that's open, so I'm going to make an open circle here, and I will erase this portion here. Erase, erase, erase. Okay, then I'm done with that. Then the next one here is 5x. 5x is a linear function. Y equals 5x. The mean is that one is the slope is 5, the y-intercept is 0, so you start at 0 there, and up 5. 1, 2, 3, 4, 5 over 1, 1, 2, 3, 4, 5 over 1. Okay, so you can go going 1, 2, 3, 4, 5 over 1 there, and then you can down 5. 1, 2, 3, 4, 5 down 1. It's right here. Okay, you will connect those points from negative 1 to 3. The 3 is right here. Close here, close there, because they're all equal sign right there. Okay, there you go. Next is an absolute value. The meaning of that one, that's you're gonna go right 5, left down 3. So you're gonna go right 5, down 3, 1, 2, 3. This is your. You can make a table of values here. Let's review the table of values for absolute value. The middle one is the vertex, which we know here is going to be 5, negative 3. Pick numbers before 5, which is 3 and 4. After that, 6 and 7. I find 4. 4 minus 5, it's negative 1. Absolute value of negative 1 is 1 minus 3 is going to be negative 2. 3 minus 5, it's going to be negative 2. Absolute value of negative 2 is 2. 2 minus 3 is negative 1. And that will be the same thing there. So you plot the points. 1 over, 1 over, 1 over. Okay, but do we need the entire points? No, we only need everything greater than 3. 3 is right here, so everything right here, like a Nike, check. And then we don't need that one. That's open there, so this should be open. Okay. All right. This time we're gonna do the inequality of quadratic inequality. So f of x is less than 3x minus 2. Again, some review. If you have a greater than or less than, we're gonna have a dotted line. If we have a greater than or greater than equal to, we're gonna shade above. If you have less than or less than or equal to, we're gonna shade the below portion of the graph. Okay. All right. So if let's graph it now. So 3x squared. So there's a vertical stretch because the value of a there is equal to 3, which is bigger than 1. So it's going to be wider, narrower the wings of the graph. And let's make a table here. So since there's a negative 2, that means you're going to go down by 2. So 0, negative 2, that is your vertex. 0, negative 2. And since a is positive, it's going to open upward. All right. So pick numbers before 0, which is negative 1, negative 2. And after that is positive 1 and 2. We will plug in the negative 1 on the equation here. Negative 1 times negative 1 squared is 1 times 3 is 3. 3 minus 2 is going to be 1. If we plug in negative 2 squared is 4. 4 times 3 is 12. 12 minus 2 is 10. Okay. And this will be the same thing also here. Okay. Just to save us some time, but I would like you to double check your answer with 1 and 2 there. Okay, so negative 1, negative 1, 1 there, and negative 2, 10, which is the top one there, and reflection on the other side. Make it a U shape. If you notice, it's kind of tight and closer, because of the vertical stretch with a scale factor of 3, because that's 3x squared. Okay. All right, and hold on. Since this one here is less than, we need to connect them with a dotted line. So I'm going to erase some here. And for the shading, since it's less than below, the below portion of the graph is the one outside it here. Okay, there you go. Very easy, right? All right, last one here. Y is less than, again, 1/4 of x plus 1 squared plus 2. This one is telling us it's going left 1 and up 2. But the 1/4 is telling us it's going to be a compression by a scale factor of 1/4. Okay, so we expect to be a wider here, and we might need a calculator here. So since we know that the left one up to, left one up to, we know that that's our vertex. -1 up to, that's your vertex there. Since 1/4 is positive, it's gonna open upward. So pick numbers before -1. So I'm gonna have -2 and -3, 0 and 1. If I'll plug in the 0, I think 0 is a lot easier. Maybe, I don't know. So let's plug in the 0 first here. 0 to the 0 plus 1 is 1. 1 squared is 1 times 1/4 is 1/4. 1/4 plus 2 is 2.25 or 2 and 1/4. Okay. Oh, no, no, I'm wrong, wrong. It's not there. It has to be on the 0. 2 and 1/4 or 2.25. Okay. If we plug in the 1, 1 plus 1, it's 2. 2 squared is 4. 4 times 1/4 is going to be 1. 1 plus 2 is 3. Is 3. So this will be 2 and 1/4 also, and this will be 3. So now I'm going to plot the points. -2, 1/4 is right there. -3, +3 is going to be there. Reflection, reflection the other side. And there you go, like a bowl. All right, there you go. That's the parabola. And the vertex is -1 and 2. It opens upward. And the domain here is all real numbers. The range here, the lowest point there is -2, bracket, infinity. Alrighty, there you go. And that's how you graph quadratic equation and inequality. As always, kaboom. Time to go home.